All right, we've got 4 sections we're doing this practice test for. And yes, we did skip 4.3. That was the one on using the calculator to get a curve of best fit. And we're not going to do that because it's not a standard. So now we've got quadratic functions and transformations. I know it seems like forever ago, but we actually started off with graphing parabolas. So we've got to remember how to do all that. Graph each quadratic function. Name the vertex, axis of symmetry, the maximum or minimum value, and the domain and the range of each function. So I look at this formula, y equals the quantity x minus 2 squared plus 3, and hopefully we realize that that's vertex form. Because we had 2 forms. The first one we learned about was vertex form, the second was standard form. So let's start with the most important piece of information first. What's the vertex for this particular parabola? 2, 3. Now remember, because our parabolas only open up and down, our axis of symmetry goes this way. So what do we write for the axis of symmetry? X equals 2. Yeah, don't forget the x equals 2 because it's a line. And lines have to have that x to the first piece in there. So x equals 2. So we're supposed to know already whether or not this has a max or a min. Well, I think we do. Does this parabola open up or down? It does open up because it's like a little positive 1 there. So it's going to do that. Now, at the bottom of that parabola, what's the name of this special point right here? The vertex. So don't we already know what the y is going to be down there? What will the y be? 3. And we probably better circle that it's going to be a min. Now again, I'm not going to take off if somebody does min and then writes the ordered pair 2, 3, but 3, really it's the y value that we're talking about for min or max. Now we might want to graph this one before we start talking about domain and range. So let's get our little vertex on at 2, 3. Put our axis of symmetry on there. Like so. But really, what we want to do is take the parent function and move it, right? So I try to remember what was the parent function. Do you remember what we use? Yes, because this is a little imaginary 1 right here. Now we have to take a along with, so in this case it's going to be y equals 1x squared. So we just go with our 9, 4, 1, 0, 1, 4, 9. And that's going to be our parent. So we'll get that on there, dashed or dotted. I'm just going to leave it like that so that I don't have too much messing up my picture up here. And then we'd move it 2 to the right and 3 up. Now my 2 to the right and the 3 up for my 3, 9 is going to be off the chart here. But at least it gives me something to aim at. And there it is. So again, the original, the parent function, always use y equals ax squared. Let's see if we did everything they wanted. Vertex, axis of symmetry, max or min. We still have a couple of holes down here. Domain and range. range. What's our domain? All reals for all of our parabolas, all reals. But we are not using all the y's. So what should we put? Out loud, please. Yeah, y is greater than or equal to 3. Remember, we said that was the min. That 3 value for the y, that's the min. Got it all. It's all on there now. We're good to go on. And we have another one. But this one is in standard form. Graph each quadratic function, name the vertex and the axis of symmetry, the maximum or minimum value, and the domain and range of each function. What did we start with for the first one? The vertex. Yeah. Well, we might as well start there too, but we have to remember our little formula. So what's the formula to find the x-coordinate of the vertex? Good. Negative b over 2a. Now, some of you, I remember, still like to do this in your homework. You can do that. Otherwise, you can just look up there and say a is negative 2, b is negative 12, and c is 11. Totally up to you. Whatever keeps everything organized for you is what you should use. So we'll have the negative of negative 12 over 2 times negative 2, which is a positive 12 over a negative 4. Gives us a really nice little negative 3 for the x-coordinate of our vertex. Now, how are we supposed to get the y value? Yes, we have to plug it back into the original. So, negative 2 times negative 3 squared minus 12 times negative 3 plus 11. And if I were you, I would write it down exactly like that, and I would punch it in exactly like that. The parentheses are going to make sure that the calculator knows when we want a negative 3 squared. $29. Woo! All right, so where's our axis of symmetry? X equals negative 3. Does this parabola open up or down? This one's down. So does it have a max or a min? Has a max. What number is going to be the max? The 29. Now, we have to graph that. And on the test, you guys are probably getting one that'll fit negative 10 to 10 just fine on here. But if you can't fit everything, then you have to change the intervals you go by. Our x's are going to be fine, but we've got to be able to get to 29. So we probably better go by 3's. So I'm going to label it down here, y's by 3, because there's no way I can write an itty-bitty little 3 on there that anybody's going to see. If you can write that small, and you can write 3, 6, 9, 12, 15, 18, well, then do that. But I know I can't with this big, thick marker up here. All right, so let's get our negative 3, 29 on there. 1, 2, 3, and almost 30. Up there. And then I can get my axis of symmetry. But that is definitely not a parabola yet. So what do you suppose we should do? Well, let's start this way. With this, there was kind of a freebie easy point. Anybody remember that one? 0C, yes. So 0, 11. 3, 6, 9, not quite 12. And because of symmetry, 1, 2, 3, 1, 2, 3. So negative 4, 5, negative 6. and 11 will also be on there. What do you think? Is that enough points to make a parabola? On the test, I might want, maybe just one more. Try putting like 1 in. Let's see what happens if we put 1 in. So we'll have -2 times 1 squared minus 12 times 1 plus 11. And yeah, you could use your calculator if you want to use your calculator. I'm going to do this one in the noggin here. So 1 squared is 1 because you have to do exponents first. -2 times 1 is -2. -12 times 1 is -12. So we have -2 and -12, -14. -14 plus 11. What's that? So we've got 1, -3, and I went by 3s, so that's just 1 unit down. And with symmetry, -7, -3. And I would say that's a pretty good look at our parabola. That's not too bad. You could always put some more points in if you have time after you're done with the test to go back and pretty it up. What's our domain? Yes. Speaking of freebies, right? That should be a freebie. Range, you have to think about a little bit. What will that be? Y is less than or equal to 29. All right, let's make sure we did everything they wanted. Vertex, axis of symmetry, max or min, domain, range, graphed it, boom. Got it all. So, little formula to memorize, x equals -b over 2a, if you haven't already. So far, so good? Coming back to you a little bit? A little bit? Anybody have any questions on this one? So you'll have one of each. You've got one to graph that's in vertex form and one to graph that's in standard form. Now this one says we can't graph it. Buggers! Without graphing, name the vertex, axis of symmetry, the maximum or minimum value, and the domain or range, and the transformation of the function. Oh my goodness. Is that in vertex form or standard form? Oh, well then this shouldn't be too bad. That's vertex form. So what's the vertex? 3, 2 it is. So what's the axis of symmetry? X equals 3. Does it open up or down? Down. I know it said don't graph. I'm not graphing. I'm sketching. That's a sketch. So does it have a max or a min? Has a max. And what is the max? 2. That's your highest y value. So what's the domain going to be? All reals. Now use the visual. What is the range going to be? Y is less than or equal to 2. Excellent. So vertex, axis of symmetry, max or minimum value, domain and range, transformations. Well, the parent for this one is y equals x squared. But this obviously has a lot more going on than y equals x squared. So we've got to explain what all the numbers are doing. What's this negative in the front do? What's the fancy name for that? Reflect. Reflect over the x-axis. How about the 4? Big vertical stretch. Vertical stretch factor of 4. Four times all the y's. How about the x minus 3? What's that going to do? Good. I love hearing the fancy name even. Translate 3 units to the right. And up 2 units. Or 2 units up. However you want to write it. Got them all? Yeah, we had to explain the negative and the 4, the 3, and the 2. Got it. So we didn't need to graph it. But a sketch, really helpful. Alrighty, the students in Mr. Wilson's physics class are throwing golf balls. Oh, of course they are. The flight of group A's ball is modeled by the equation y equals negative 0.14x squared plus 0.68x plus 6, where the height y in feet can be written as a function of x, time in seconds. Oh, goodness. First question would be, what does this parabola look like? It's down, isn't it? Well, finding the maximum height is really finding the what? We don't have to use the calculator for this one. If you wanted to double check, that would be great, but we know the formula for finding that vertex. What do? X equals negative b over 2a. We're going to figure out what the x coordinate is, and then we can plug it back in and find that maximum height. So we will have negative 0.68 divided by 2 times negative 0.14. And then, good habit to get into, parentheses for both the numerator and the denominator. We wouldn't need it for the numerator on this one, but better safe than sorry. If there's only one term, then usually you don't have to use parentheses. But let's see what we get. Parentheses, negative 0.68, parentheses divided by, parentheses, 2, parentheses, negative 0.14. So about 2.43. I'm going to put my little squigglies. 2.43, and x was seconds. So at 2.43 seconds, it's going to be something for height. How do we get the height? That's what we do. Plug it in. So that's kind of a monster. Negative 0.14 parentheses 2.43 parentheses squared plus 0.68 parentheses 2.43 parentheses plus 6. Whew! 6.83. What was the label for height? Feet. So I'd probably put a box around that. So we didn't have to have a graphing calculator. Now, could you plug the whole thing in the calculator and find the maximum height using Blinky? Yes! If you know how to do that and you like doing that, do that instead. So when did it reach the maximum height? Oh, I put this in the wrong slot, didn't I? This one is for here, and this one is for here. For the maximum height that the golf ball reaches. So now, Bobby throws the golf ball to Connor, who makes a spectacular catch of the ball 6 feet above the ground. How long was the golf ball in the air? Oh my. So that means this right here, this y value is supposed to be a 6. Now, that's unless they changed the labels on us. Did they change the labels on us? Excellent. They didn't. Feet and feet. Love that. So now it looks like this. Oh, except my 8 is looking goofy. All right, so 6 feet above the ground. How long was the golf ball in the air means we have to figure out this. That's not the vertex. What's that? An x-intercept. What's another name for it? This was Fridays. Solutions, also known as Zeros. Does that have a 0 on one side? Easy enough to get it there. Remember, I said you wouldn't have to use a graphing calculator to do the problems on this test if you didn't want to. So I look at that and I think, well, the rest of the test is going to be factoring. I wonder if I could factor that. Is there a greatest common monomial factor? And if so, what is it? Let's take it out. Well, we already know about this one. This is when he threw it ball. That was at x equals 0. That's not the one we need. We need the one from this mess. If we want to answer it. Well, that's just a two-step algebra equation, for goodness sake. We can subtract 0.68 from both sides. And divide by negative 0.14, because we've got a calculator. So let's see what that comes out to be. Negative and a negative will be a positive. I just need 0.68 divided by 0.14. 4.86. 4.86 what? What should our label be? Seconds. Now, could you plug this into the calculator and use Blinky to find the 0? Absolutely. If you were good at that on Friday and you want to do that, do that. But this way you're showing work, and you wouldn't have to use a graphing calculator if you didn't want to. You know, we always show you how to use it, but then you have the option of doing this by hand instead. All right, now we're factoring like crazy and factoring to solve. Oh, we're going to skip this chicken problem. There's not going to be one on the test, so I'm going to skip the chicken problem, even though I like the chickens. There it is. So these just say factor completely. So we're not solving these, we're just factoring. X squared plus 4x minus 12. You got to go through that magical list in your brain. Is there a greatest common monomial factor? No. Is it a perfect square trinomial? No. Good old-fashioned factoring. Gosh, I hope so. Find the two numbers, please. What are they? Multiply to negative 12 and add to 4, plus 6 and minus 2. Number 7 over here, go sideways. Number 7. Greatest common monomial factor, something we can pull out of all of them. But maybe this is a perfect square trinomial, because this is a perfect square. It's 3x squared. And the last is a perfect square. It's 2 squared. Let's check. 3x times 2 doubled. Does it work? It does. So that means we have to write it one set of parentheses squared. Now when they say it, what's it? What goes in there? 3x minus 2. So 3x in front, 2 in back has to be a minus because the middle term has to be subtraction. Take a look at number 8. Greatest common monomial factor? Yes, negative 1. Pull out a negative. Do we have a perfect square trinomial now? No, 72 is not a perfect square, right? Okay, so now we're going to hope for good old-fashioned factoring. Do we know two numbers that multiply to 72 and add to negative 17? What are they? Negative 9 and negative 8. Got it. There it is. And remember, if you have to make the list, make the list. You know, you just have to be able to find them. Oh my, number 9. Oof. I think there's a greatest common monomial factor there. What do we have? A -5. Anything else? And an x. We got a lot we can pull out of that one. So again, you can just think backwards. -5 times something will give me -5xy squared. Oh, it's only missing the y squared. -5 times something gives me 30xy. -5x times something plus 6y. -5x times something will give me -25x. That's a plus 5. We might not be done. There's still a squared up there. Well, it's not a perfect square trinomial because 5 is not a perfect square, but maybe, just maybe, and be careful to use y's with that one. Do we have two numbers that'll make that work? 5 and 1. That makes that work. Beautiful. Number 10, do we have a greatest common factor? We do, don't we? 64 divisible by 16. Let's check. Well, looky there it is. So we need to take that. We have to take that 16 out of there. Oh, wait a second. I think we're supposed to know that pattern. X squared minus 4. Hey, those are perfect squares. So we've got 16, but then how do we make sure there's no middle term? Good. X plus 2 and x minus 2. Opposite signs, no middle term. 11, greatest common monomial factor. I'd really like to take the 4. Can I take the 4? Rats. Hey, maybe it's a perfect squared trinomial. That's 2x squared. Oh, golly, that's not. So this is a combo problem. Integers that multiply to 4. First times first. In the back, integers that multiply to -15. -1 and 15. 1 and -15. -3 and 5. 3 and -5. Did I miss any? All right. Well, we need outside times outside plus inside times inside to give us -7. See if you can find it. Anybody have it yet? Keep looking. It's there. How about now? Anybody find it? Okay, well, did you start at the bottom? And you went through all of that and none of it worked, right? So this one's out. So then you go, Jacob. It is. Outside times outside, +5. Inside times inside, -12. And that adds to -7. So first, last, and last. And they have to go in that order. Remember that outside times outside plus inside times inside was really important. So far, so good? So Do you agree 11 is going to take the most time out of all the factoring problems? Yeah, because you have to do the combo problem thing. So now we have to switch gears, because now it's not factor, it's factor to solve. Solve each quadratic equation by factoring. So take a look at number 12. Does it have a 0 on one side already? Well, that is very helpful. So then we check for greatest common monomial factor, something we could pull out of 9x squared minus 4. Oh, but wait a second. That's 3x squared, and that's 2 squared. Well, maybe we don't need to pull anything out. So how do we make it so there's no middle term? A plus and a minus. But now we're not done. We haven't solved. Remember, if that 0 is there, you have to say 3x plus 2 equals 0, and 3x minus 2 equals 0, and you actually have to find the numbers that would make it 0. So subtract 2 and divide by 3. Add 2 and divide by 3. Negative 2/3 and positive 2/3. Got them. 13. Oh, is there a greatest common monomial factor over there? Because it is already a 0. Oh, this is a combo problem, isn't it? All right, 1 and 5, 5 and 1. They have to multiply to positive 21, but add to a negative 22, so they're both going to be negative. Good news is there's not a lot of them. So see if you can find the negative 22. Anybody got it already? This one? Negative 35 and negative 3? Too much. Yeah, it's the other one, 1 and 5. Negative 7, negative 15, there's your negative 22. So it's just backwards. So x, 5x in front, and then minus 3, minus 7. Are we done? You know what happens every year, don't you? I grade somebody's test and all they do is factor on these, and then I have to take points off because they didn't solve. So yeah, they get some of the points, they're just not going to get much because they didn't solve. Add the 7 and divide by 5. So 3 and 7/5. Again, checkable. You could, if you have time when you're done with the test, go back, plug them in, put them in for x. Make sure they give you 0. Alrighty, 14. Is there a greatest common monomial factor for 14? Is it a perfect square trinomial? Oh, now we're already down to good old-fashioned factoring, but this time it's only an x squared in the front, and we all know x times x gives us that, so that's easier factoring. 2 numbers in the back that multiply to 32 and add to negative 12. Negative 4, negative 8. And then we find our zeros. Because it's a test, we probably want to show the work there. I know it's easy to look up there and say, well, this would be 4, because 4 minus 4 is 0, and this would be 8. But on a test, show the work just in case you mess up and write down the wrong number. Number 15. Greatest common monomial factor? No. Perfect square trinomial? Maybe. Let's check. 3x squared, 1 squared, multiply it and double it. Does it work? Woohoo! So that means we can write it as something squared. What's the something? What goes in between? Minus. So now we only have to do the math for one of them. Because again, this one counts twice because it has a little power of 2. That's called multiplicity, but we'll deal with that in the next part of the chapter. So we've got an x equals 1/3. That's the practice test. Again, the chicken problem won't show up on the practice or on the test. So because of time, I wanted to make sure that we had enough time to get through everything you needed here. So anything you want me to make another one of? We're going to be good? Alrighty. So that was our practice test, and now if you don't already, double check for that little yellow slip of review homework and let me know if you need one.